right. Let's get back in the swing of things. Okay, this is the folder where we're going to be working on. It's in your folder, so you need to have this out. We glued it in class. So we're going to really quickly fill out this so we can start tomorrow on this. We're, of course, already starting behind. Let's label. We did this in class. We talked about our quadrant plane, and the reason we did that, not only do we really need to focus some more on this, but it goes into this. We're going to be graphing some proportional and non-proportional relationships. And to do that, we have to be able to understand quadrants and coordinates and that sort of thing. So we're going to title this coordinate plane. And this is our note. So you can refer back to this. That's why we built this. Okay? So you should have this all said and done, and how to map and list coordinates. Okay, so now we're going to talk about proportional and non-proportional relationships. Okay, guys, a proportion, I just want to reiterate, I'm switching it around here. A proportion is, remember this. So if it was two dogs to 3 cats. This is dogs, this is cats. If I had this was a proportional relationship and I had 6 dogs, how many cats would there be? Well, you would have to, as we've talked about, cross multiply, divide. So 3 times 6 is 18, divided by 2 is 9. There would be 9 cats, okay? We've solved a lot of these. This is a proportional relationship. But we know not all numbers and not all patterns go proportionally. Most that we've dealt with this year do, but there are a few that do not, okay? Sometimes you get a raise and it's done in percent, or it's done, you just get a 50-cent raise. Well, that doesn't necessarily mean it's a proportional relationship, okay? So there are times that things change non-proportionally. So I want us to be able to recognize proportional relationships and non-proportional relationships, okay? Again, we're going to mostly focus on proportional, but realize if it doesn't fit proportional, it has to be non-proportional, because all it is not proportion. Okay? So this is, we're mostly going to be talking about what is proportional, because that's our main focus. But if it doesn't fit this category, it fits this category. Okay? Alright. So, the first thing, for a proportional relationship, it has to contain the origin. That is just like saying, with my example down here of the dogs and cats, they're a proportional relationship. What if there were no dogs? Well, then there would be no cats, because every 2 dogs, there's 3 cats. I mean, that is how this is a proportional relationship, okay? Think about money. If I get paid $5 per hour, so if I don't show up for work, I don't get paid. I get no money for no work, okay? So, it always has to contain the origin. And we talked about the origin today. It's in the middle of the graph, okay? Data is linear. Alright, so all that means is it makes a straight line. So starting at 0, 0, I want you to draw a line. Okay? It makes a straight line. Linear means line. So if you're given a graph and the line curves, it's not a proportional relationship. Okay, we've also talked about this. It must have a constant of, oh, I jumped down here, proportionality. We've done a lot of constant and proportionality. It is, remember, it is the y divided by x. Okay, we've done a lot of this, and we decided the constant is called a k. All right, it can also be called an m. And it has a constant rate of change. You know this term because that's what I called constant of proportionality. Constant rate of change is a unit rate. Again, this is kind of a review from what we learned earlier in the year. Okay? The equation. The equation will always be y equals kx or y equals mx. Okay? Remember, m and k, same thing. They're just terms for our constant. And it's essentially, it always has to be a multiplication relationship. So it must have multiplication. Okay? Because that is what's happening between the k and the x, or the m and the x. And the opposite of multiplication is division, so that's why we always divide for this. So everything we've learned are kind of all coming together, and we're going to be graphing some of this information. Okay, so this is proportional. Let's talk about non-proportional. It's pretty much everything this has, it's the opposite. So if a proportional relationship had to contain origin, it may or may not contain origin. So what it's saying is it can start at origin, but it doesn't have to if it's a non-proportional relationship. It may or may not be linear. And I'm going to give some examples. Alright? So, this one right here, I'm going to start at this 2 and go straight up. So, that is a straight line, but notice it doesn't start at origin, so therefore not linear. So, not proportional. It is linear, but it's not proportional because it doesn't start at origin. It doesn't start at 0, 0. Or, this one I'm going to draw, it's going to actually start at origin, but I'm going to curve it. See how it curved? That means it's not linear. So this whole may or may not, sometimes it can be a straight line, like proportional relationships, but it didn't start at origin. Or in this one, it starts at origin, but wait, it's not linear. It has to be both for it to work. Same thing comes here. It may or may not have a constant rate of change. And the note here is the constant rate of change is what makes it a linear relationship. So what makes the straight line is a constant rate of change, but it must start at origin to be proportional. Oops, I'm running out of room. Okay, so it can have a constant rate of change, and it will be linear just like this one, but it will not be proportional if it does not start at 0. Okay, and these relationships are more an 8th grade thing. These that are going to have a constant rate of change but not quite 0. But you 7th graders, you need to learn this, and you 6th graders, this is what we're working toward. This is why we learn proportionality. Okay, but the big thing, it has no proportion, it does not have a constant of proportionality. Okay, so the formula y divided by x is not the same every time. Okay, so that is going to be our big one. So I want you to put a star or something, highlight, make it this one important. It won't have a constant of proportionality. That's the big thing that makes a non-proportional relationship. Okay? Now, the equation will never be y equals xk because we don't have that k. That's why it will never be that. Sometimes this is what it will look like. Y equals kx plus b, or more common, mx plus b. Okay? This is called slope intercept form. Again, this is more an 8th grade thing, but we will be talking about this. So kind of get used to this relationship because these are going to be all non-proportional relationships, okay? If it has this plus, it cannot be, because remember, to be proportional, it has to be just multiplication. So it not only multiplication, and I'm just going to do the thing, it can have adding, subtracting, and division. So this non-proportional relationships can have all of them. It doesn't have to just be multiplication. Okay? So it can have more than one thing. So this is our quick notes on proportionality and not what is non-proportional and what is proportional. So we're going to title this proportional versus non-proportional. Okay, you need to have this done, and we're going to start talking about it because tomorrow you're going to walk in and I'm going to give you some tables. They're going to look like this. And you're going to decide if they're proportional or not proportional, what is the constant of proportionality, and then you're going to write the equation. Okay? And I'm going to show you really fast how to do one so you can immediately get started. So I'm going to know who is prepared and who is ready and who is not. So I'm going to know really fast who has watched this video and who has not. Okay, so how to tell when they're in a table situation. Remember, we have to find the x and y. Remember, we have to find the constant or of proportionality, which is y divided by x. This is my y, this is my x. So I'm going to have to go 54 divided by 2, 81 divided by 3, 108 divided by 4, and 135 divided by 5. Okay, you're going to use your calculator and you're going to divide those numbers. If they all divide to be the same thing, that is your constant of proportionality. So 54 divided by 2 is 27. So we think K is 27. 81 divided by 3. K is 27. 108. And you have to do it to all of them to make sure. Whoopsie. K is 27. K is 27. So, is it proportional? Does it have a constant of proportionality? Yes, it does. Or is it proportional? Yes. The constant of proportionality is K equals 27. The equation is, remember our equation is y equals kx. So for K, I'm going to put in that number. So y equals 27x. So I'm going to give you this exact same paper. And I've already answered number 1 for you. So, not that I expect you to memorize this, but this is how we're going to solve each one of these problems. So, get ready. This is what tomorrow is. You're going to use this knowledge and your calculator and your brain, and you're going to answer this. That's what we're going to do right when you walk in. Alright, bye guys!